And welcome to cs312 Database Management. Say hello, everybody.
Hello.
All right, gonna have lots of fun today. The plan is to look at our relationships. Very important here at Emmaus. But first of all, just look at the database relationships from the nicely diagrammed. You know how to get to relationships in Access?
Yes, all too well.
Mr. Camper database over there. Well, over here in cs312, we have some databases for you. Please go to your resource files, chapter 4, and download the Tiny College database. Notice the suffix on the Tiny College database is MDB. That's the old version of databases. Go ahead and download that. If you want to, let's see, mine wants to save, and I'm going to save it to my little cs312 folder. I'm going to call it Manning2 because I've downloaded this a few times already just to play with it. And then start up Access and go open it.
So not Tiny College. Oh, no.
Just the regular Tiny College. But the plan is today to look at that one, also to look at the famous Northwind database, and then do a little bit more playing in MySQL. Let's see if I can get access. The recorder is messing me up. It's not letting my toolbar come to the unhide because the border is right there where the toolbar is supposed to be. So I guess I have to do the Windows Access. There it is, Access 2016. Little warning for you, don't install Office 2013 and 2016 side by side if you can help it, because if you start up one after having used the other, it goes through the whole reconfigure process. Very painful. Okay, so I'm going to close this table. This is the old one I had up. I'm going to open from Access that one I just downloaded. I don't want to do that. I want to go File, Open, and I'm going to browse to where I just downloaded that one. And here's the Tiny College. And because this is the old version of database, the .mdb, I'm still going to enable content, but first thing I'm going to do is do a file save as in the new format. And save it as, you can save it in the same place. I have my cs312 folder. Save it as in the new format. And it'll warn you, wait a minute, it's not going to be compatible with anything older any longer. The reason to do this is if you're using the old version, some features you don't discover till later on that they're not available, and it just gets very confusing. So right away, save it in the latest format.
Which one was I supposed to open? Because I did the Chapter 2 Tiny College MDB.
Chapter 4, Tiny College.
That would be why.
And while you're there, while you're waiting, you can install or download the Tiny College sequel.txt. You can save this link as, you don't need to open a text editor, but you're welcome to look at it in a text editor. I'm also saving the sequel file. That's going to come back later. Okay, so back to Access then. Having it open in Access, where do you go see the relationships? Database tools, relationships. Take a look at those and tell me what is wrong. There's something wrong there. I'm going to rearrange these a little bit, and the graphics go a little wacko here. I like to see everything in my table if possible, so I'm going to get that cursor right to the edge, enlarge them just a bit so I can see all my members. Unless it's a huge table, I like to see everything inside of there. And this serves as sort of an entity relationship diagram for you. And I get to the right spot. That's that lovely new interface. No borders to let me give you a grab handle. That's the flat look and feel of 2016. Somebody at Microsoft must like it. There we go. Now I can see every entity. I can rearrange them.
Shouldn't the course and department be connected?
Yeah, do you see there's some missing connections here. Department code should be linked to department code here. That is correct. There's also another missing link. Our professor number for our class isn't connected to the professor table. So there's a second error. So Chris gets extra credit for finding the one I wasn't thinking about. Department code should have a relationship to the departments table. Now let's see. Well, first of all, everyone able to get to that? All right, scream if you can't. Now, we want to see if we can establish those relationships. I'm going to try this one first. I'm going to just click on that and drag it to this department code. This is how easy it is in Microsoft Access. And we do want to enforce referential integrity whenever possible. And can anyone explain referential integrity?
What we do, department codes from. It makes sure that whenever you put the department code in the professor table, it actually exists as a department.
Excellent. The department has to exist. You can't name a department that doesn't exist. You have to fill it in the table where it is the primary key of that table, then refer to it. And remember the cascade update and cascade deletes? If you happen to delete a department, instead of leaving this professor orphaned in a department that no longer exists, it will force you to choose, assign him to a different department, or delete that professor if he doesn't have a department anymore. So the cascade update and delete are even more guaranteeing that you will maintain integrity of your table. Usually I leave those off at the start just to see, can I create the relationship? And that one indeed can be created, so I'm happy about that.
So, okay, how did you add that? I'm sorry.
I just drag department code. I'm going to do it again because I need this guy to be linked. So I drag department code, click and drag, department code there to department code there, and enforce referential integrity. And then click create.
Alright, so click.
Uh-oh, it doesn't like that. What's the problem? I dragged it from the wrong table.
So we need to
It's a foreign key in this table, and it's a foreign key in this table. You have to drag it from the primary key of one table to the primary key, to the foreign key of the other
So you
table.
need to click and drag it from course to department.
Oh, it already has that relationship. Wait a minute.
Same relationship is what it's saying.
Employee numbers
Huh.
and various.
I didn't realize you couldn't establish the two. Well, I guess it makes sense. You can't establish the two
Right,
relationships.
you can say stuff, right?
You know that
Say
they're
no, it
related.
creates a new relationship.
Wanna try that again? Let's see. Department code here, it should match.
Yeah, so.
An existing
drag that over to
department.
code, and then just say yes. I mean, no, you don't.
Oh, there we go. There we go.
It's saying that did you make sure you don't want to edit the employee number.
Oh, and look what it does. It actually, in order to avoid confusion, multiple lines between two boxes, it actually creates a second department one table, just to indicate, because it does not like to have more than one line drawn between two boxes.
How did you change the relationship type?
Oh, enforce referential integrity.
That's
And remember, I can always delete relationships by right-clicking on it, delete, and then I can delete that table or hide the table in case I didn't want that.
I clicked
Now,
it
so this is the easy one, the department code.
because I did
Which one are you doing, Josh?
from force to department. I clicked and dragged the department code, and then I clicked enforce the referential integrity, and then it's still giving me the no unique index found for the reference. Whatever.
Okay, so you had this, department code here, to department code here, and enforce referential integrity, and create.
Screw it, I'm starting it over. 'Cause apparently it's-
At first, I accidentally dragged it from course to professor. That's where it does not want you to, because it has to be a primary key in one or the other tables.
Okay, so department code.
It has to be a primary key on one side or another. Now there's another problem. Remember the one I mentioned? There's another missing link.
Professor.
Yeah, the professor needs to be referenced in the class he's teaching. Right now, all we know is that a course is taught by somebody in a particular department. But here, we want to specify who the professor is that's actually teaching. So let's watch what happens. We got a big problem here. Professor number to employer number here, employee number. That should be the matching professor number. Oh, it looks like it's happy. I try to enforce referential integrity and create. Relationship must be on the same number of fields with the same data type. Okay, there's a problem here. We got to find the problem. They're not matching data types. So I close my relationships and save changes. Oh, I want to link the professor number here has a relationship to the professor's employee number. That's what's supposed to be here. So in order to establish this relationship, it says, wait a minute. Oh, it won't enforce referential integrity. Dragging there from there and enforcing referential integrity, it says there must be on the same number of fields with the same data types. So we got a problem with data type on the professor number. So we need to do some investigation here. Okay, so let's go look.
Professor number, the employee number?
Yes, yes.
Okay, that's
I would have called it employee number rather than, or professor employee number, but they just call it professor number, leaving some confusion of where in the world this could be. But by analyzing their business rules, I saw, wait a minute, that's the employee number of the professor. So I have to close this so I can go check my data types. So let's look at the professor table first. Right-click Design. Right-click Design of the professor, and I see that employee number is a number, and I click on that field and I see it is an integer. Okay? Since it's a primary key, I probably want to leave it alone and not mess up my table. So it's an integer in the professor table, and I can view the data, and I see, yes, indeed, there's lots of professors, and there's just a number, or lots of employees as well. Okay, so I close that.
It's the same thing with the employee number.
Well, let's take a look. It's in the, remember, it's the class table that refers to who their professor is. So design view of the class table, and I look at professor number. It's a number, but looky here. Somebody made a mistake and set it to be a double. But before I change it to be an integer, let me check to make sure that they're already all integers and doesn't have professor 114.5. That'd be the mini professor, just like we have a mini ed.
On the whiteboard.
So we change the field size from double to integer.
Wait, so what's the difference between double and integer?
A double is like, it lets you do fractional things. The only times you use double is like when you're measuring something fractionally.
Okay.
If we did have professor 3.5, then we would want doubles. But somebody by accident made that a field size of double.
Would short
Short would also work.
or long?
Yeah, short and long are also integers, but they're just how far they can count up.
Can they do decimal points as well? I can't remember.
Well, that's what floats do. Floats have decimals, but not shorts and longs. Shorts, longs, bytes, they're all types of integers. Okay, so we make that an integer, and then we have to save the changes, and it's going to make a scary warning message. If
How do you save it? Just exit out.
just Control S or close it, and it'll say, do you want to save changes? Control S says, size one or more fields has been changed to a shorter size, data's lost. I want to continue.
Yes.
Notice how I check the table first before changing them to from doubles to integer. So I knew I wasn't losing data. Okay. We should have our problem solved. So I'm going to close the class table and go back to database relationships. Remember when Access is happier when things are closed. You don't have a lot of things open. Let's go back to relationships. Now let's establish the class professor should be linked to the employee number in the professor table. Enforce referential integrity, and uh-oh.
Did you know this was going to happen?
Yeah.
I feel discouraged.
The
That's how
data
that's how I teach
violates
access to.
referential integrity rules. Now this is a little more confusing, but don't fret. It's just means there's a professor listed in the classes that doesn't exist.
How dare they?
We have a class and they're gonna come and the students will sit there and they'll never know when to leave, and they'll come back at the end of the semester, find a bunch of dead bodies.
Oh.
That was a jump a little bit.
See how important it is to not break referential integrity.
Yes, I do.
It happens at camps. If you have a camper that does not have referential integrity, they get lost in the woods. They disappear. So I create that relationship. It will let me create the relationship, but I can't establish referential integrity until I fix my table, or fix the data actually.
Well, hold on, so
Wait.
we can make
You
it?
can make it without referential integrity, but we do want to, so we're going to leave it that way and come back to and edit it.
What is connected in that?
Professor number to employee number in the professor table.
Oh.
Okay, so I'm going to close this table, or sorry, close the relationship, saving changes. Now, I have to examine both tables to figure out where is the problem. So I look at the data in my class table, and I'm going to set it side by side to my professor table and find out which professor is missing. There's my classes with their professor numbers there, and open the professor table, and I'll set it over here,
Surely there's some manner of query.
and I can sort them. Yeah, there probably is a query. There is a way to do a query. How I've done it is I'll set a flag of yes, it is in that table by running an update query, and then I'll see which one does not have that flag set.
Could you back up a little bit to what you did to bring those up?
Oh, I just double clicked on the table.
Double clicked on the professor table?
Yep, and double click on the class table. And then you can sort the data by professor number. Now I can easily find 103 is there. Oh, wait a minute. There's no professor. Oh, the class. The class has to refer to an existing professor. 105 is there. Can you find the missing professor? Excellent! Kelly, you're quick. Professor 325 does not exist.
So we just have to add him to the professor table.
Or maybe they just had a typo and they meant to refer their math class. Who do we have for math professors? 155, 297. So those are the only two math professors. So you can pick one of them, or you could add a professor to 325. I'll let you choose. I'm just going to change it to an existing professor 297.
So changing. Which one are we changing?
I changed professor in the class that's referring to professor 325, which is the ghost, an illegal professor, non-existent professor. I'm entering a valid math professor 297. Another resolution would be add a professor 325, and it would make sense to put in the math department, but you know, sometimes they like to teach out of their department. Those engineering guys or psych.
So why didn't we pick the other math guy, 155? We just picked a random math
I just
guy.
picked one of them, yep.
What'd you change?
Either one would be fine. Actually, any of the existing professors would be fine. Not sure about that history professor, though.
What'd you change it to? 297?
Yeah, I changed it to 297. Now, and by editing the data doesn't change the table, so I guess I did resort things. That's why it's asking me to save the changes. Now I can go back to relationships, and it should let me establish referential integrity, double clicking on that connection that I made, and now turning on enforce referential integrity, and if I've done it right, it shows me the one-to-many relationship.
Did you just drag it again?
I actually double clicked on it and just checked the enforce referential integrity. But you could also drag it again. I could delete it.
I still get.
I could always,
Darn.
now I could
Where's
drag
the
it.
Go message? Is it the same one?
Yeah, the Microsoft the one we had before when Ed felt betrayed.
A violation of the rules.
Next, I'm looking at dragging professor number from
Class to professor. Employee number.
And professor.
Well, this program is really fussier than I thought.
Enforce referential integrity.
Yep.
Create. Then I get error message.
What does the error message say?
It's the one that we had before.
The data type?
Yeah, data in the table class violates referential
Okay. Oh, it violates referential integrity. Okay.
I think he might actually
You can leave the connection there, go back to the class table, double click the data, check that there is no, you might have changed the wrong one. Math 243,
So that one needs to be changed to 297.
that needs to be an existing professor, and I chose 297.
Okay, so then what was QM 362 before the Tuesday, Thursday one? I think it's 162.
That was
That's 162.
Tuesday, Thursday, that was 162. I'm not, as long as it doesn't violate in referential integrity, we're not,
I'm
we're,
trying to put it back to
we're
where it was.
rearranging the departments, assigning professor to the wrong classes, but, that's a management problem. We're making sure the data is has good integrity.
I did it.
That's all that matters to us. We're not concerned whether history professor is teaching math. That's up to the administration to figure out. So there we fix it. Now let's go back to our database relationships and let's see, are there any other relationships that are important that may be missing? There's a student assigned to a professor. That should also probably be referring to an existing professor. Let's see if we can establish that relationship. Oh, somebody again messed up. Professor number, I bet you made it a double over there. Let's go fix that one. And that was the student table. Right click, design view. Professor number, look at that. They made it a long integer. Come on, who's designing these databases?
So why is there what is the professor number in the student table? Like his advisor?
Yeah. It's their student advisor. Typically your advisor is another professor. And even in the comments they said that needs to be a foreign key, but this is an incomplete database. They've left a few errors in there. So same thing, I go change it from a long integer to a regular integer,
That's why. What we're changing is student.
prof num, and then save changes. Question?
Yeah, you in our, not necessarily about this, you have a Monday and Wednesday next week, scheduled for that CMS?
Is that really next week?
No.
Oh,
It's
yeah, that's a error. I better fix that.
So I didn't know if there's supposed to be anything due.
Thanks for letting me know. So another, in referential integrity, we'll leave this one because I want to go on to the Northwind and then some SQL. So you can see the issues here. This is an incomplete database, but access kind of helps me out. It not only is checking, okay, that relationship is okay, but now that I have data in the table, and I can put the link there just to remind me it needs to be there, and then come back and fix the data. But access helps to make sure that not only is the relationship there, but the existing data doesn't break the rules. So this is another lesson that before you fill your tables with data, you should establish your rules. If you try to establish the rules later, you'll run into stuff like this, where way over here, the students are referring to, again, the ghost professor that left. Now we have students at advising chapel. They get lost, and we don't know what's happened to them.
And they die.
Yep. We don't get any more tuition from them because they're waiting for their non-existent professor. Okay, we'll close this and we'll come back and maybe I'll have a little extra assignment to just fix the rest of that. But I want to go to a more complex database because we want to worry about relationships, and looking at them helps you understand the database. So I'm going to close this one and go back to the cs312, and where is that Northwind database? There's a Northwind sample. It's very popular. Let's go back to the class. I think I gave you a link towards the top here. There it is, the Northwind database. And it's used in many tutorials, including the W3 School SQL tutorials. You're welcome to get a little better handle on SQL, checking out the W3 Schools. They use a SQL database very similar to the Northwind, which Microsoft has used for 10 years or more. For any examples, they always are using the Northwind. So it's good to just get to know that. So I'm going to download that one. I'm going to do this version. I think they're the same, but I last time I checked, think I use this one. Since it has the ACCDB extension, it will open with Access, but my browser doesn't know the difference between 2013 and 2016, so I'm going to save it to make sure I only open it with 2016, or I lose 5 minutes of class and I stare at my screen. Okay, so Northwind sample, I'm going to call that Manning because I've already downloaded a time or two. Now go back to Access, which I think, oh, I closed Access, so I will open it again. Here. Access. And now I will open that file from my folder. And there's my, that's not it. It's down in my cs312 folder. Now this one, all we're going to do is go through the database relationships and see if you can figure out what in the world is going on here. It's a much more complex database. There's the Northwind sample Manning. Enable content. You can close the initial dialog. All we care about in this one is the database tools, relationships. Okay, get ready. Don't have a heart attack. How do you like that for relationships? And that actually isn't a super complicated database. Usually, yeah, I mean, look at remember the Moodle tables and what couple hundred tables in that Moodle?
They're not, it's
But-
not arranged very nicely.
Right.
but-
So all I want you to do here is arrange them a little more nicely. And as you do the arrangement, I think you'll start getting some insight on to the design of this database. Now, because I'm on a small screen, it's a little harder, but I will attempt it on this small. Maybe I'll bring it over to my big screen and then bring parts of it back. So I'm just seeing the left side of it. I'm going to kind of spread things out, and you'll start to see. What I like to do is the tables that only have one connection to one other table, I'll kind of put towards the outside of the drawing. And the ones that have a lot of connections, put towards the center. And it'll start to get a little more manageable as you have the little databases, the little tables around the edge. So I'll bring this one over here. For example, the left side here, the purchase order, that's kind of central to a lot of things. All these other ones are kind of just linked only to the purchase order table. So I'll bring them around to the outside. And notice when you bring a table left or right, the little arrow will jump. And this is basically an order processing database. So employees are going to be responsible for them, but then there's numbers associated with employees that we can put out to the outside of our drawing. Orders have order IDs. Let's see, inventory is probably going to be central to a lot of things. And this one only has one connection to another table, so that can probably go towards the other side here. I'm going to enlarge my window a bit so I can do it on the other, get a little more room on the other screen. So this order details, that can be way over towards the order details table. So stretch them out and basically try to reduce the number of crossing lines. There's another one only connected to one table. I can put that up near that table. And I could even bring it to the other side of that table because he's associated. And some tables that are way bigger than they need to be, I'll shrink them down, but I still like to see everything in them. Some of these tables that are really big, you don't need to make them huge. But the small ones you can make a little smaller. And little by little, as you stretch it out, it's a little exercise in graphics as well. As you do this, you start to understand what's going on with orders and what tables, what information is connected to what within this database. Let's see, let me put this over on this side. There's a lot of things associated with an order in all these little subtables that I can kind of put all on one side of the order because they're just a single connection associated with order information. And let's see, sometimes you just can't avoid a crossing. With a bigger screen, you have a little more room to work with. This guy here, I guess I'll leave it over there.
I don't know that you can avoid crossing regardless.
Yeah, you can't completely avoid crossing, but you kind of want to reduce it. And now, as you look at the table, basically what we're doing here is we're processing orders, and when we make an order, that's kind of central to everything we're doing. We associate it with a lot of other things that are in separate tables. Keeping the, we don't want redundancy in our orders table. We don't want to keep listing the customer and his name constantly. We just want to refer to them by their ID. Same with employees. They're associated with an order. They rung up the order, but all the detailed information about the employee goes to the employee table, and the details about their IDs and privileges, I'm not quite sure what they're doing with that yet. That's something I'd have to dig through the actual code, having to do with, I guess, do they have admin privileges in the system? But those tables are extra. The main thing I can see is, okay, we associate an employee with every order. So from this, you can sort of derive or infer many of the business rules. And since this is a working database, and we sort of assume it's good design, but we'd have to be better at databases and do a lot of our own to find the flaws in this. I'm sure it's not perfect. The whole idea here is you can get a little bit of idea of what they were thinking making this database by looking at their relationships.
So what are we supposed to do for homework?
This one, all I want to do is just rearrange it and save it, and then upload it. So, giving you a little practice of this, just to see, just like reading someone else's code that has a decent application, looking at a database that's fairly well thought through gives you an idea of how the relationships can get fairly complex, but as you look through each one, you can kind of get an idea. Look, the order has an ID and has a tax status name, and that goes down here. It's connected to our tax status field of an order. Is it nonprofit or not? Why do I make this a separate table and not just have tax status be a text that I put in there? They did mention this in the book, I think somewhere, I forget exactly where. What this does is, if I have in the future additional tax status items, I don't have to redesign my database. This table is ready for me to add additional possible tax statuses. When Obamacare comes rolling through and there's 10,000 more tax statuses because of the complexity they've introduced to the tax system, I don't have to come back and redesign my tables. A database designer you do not want to redesign tables. It causes all sorts of trouble when you're trying to run queries. That a table, a field no longer exists. That was version 3 that field was called tax status. Now it has a different name. Well, you've just broken your code and have to go rewrite code. So you want to establish your items in your tables, break it down into separate tables as much as possible to avoid ugly redundancies. Remember the problem with redundancies? Why is a redundancy bad? Where I have the same employee, an employee listed with his name and company, first and last name in multiple places. What's the problem?
You're more likely to, if you have to update the data,
Right.
You're likely to make a mistake.
Yeah.
If you won't update it in both places.
Right. So that's why you break everything into tiny little tables. One reason, you don't want to have redundancy, and the second reason, even though right now I may only have one tax status, it wouldn't be redundancy, but I want to allow for modification in the future where I may have additional ones. So whenever there's a possibility of, hey, there may not be a yes or no tax status, nonprofit or not, there may be other options, point that to a table that says, okay, I may have multiple tax statuses. The table is there ready to have more records added to it without changing the table structure. Okay, once you have it arranged in a decently readable format, go ahead and save that, and then you can upload that to, I think I had a little assignment location for this one. So close and save changes. And I'm not going to be super fussy on you having the perfect arrangement, as long as it looks reasonably good, that and I could tell you've done some work on it.
I thought mine was good until I looked at Blake's.
Ah. So that's the 03 rearrange the Northwind DB relationships. Okay, I wanna look at this one now. And again, this has to deal with a SQL text file that I provided for you over here in resource files in chapter 4. Basically, they give you a SQL code to create the Tiny College database. And unfortunately, it is not complete. As I was playing with it, I realized there's even some tables missing in this. But it gives us a taste for how to work with MySQL. So go ahead and download ch04 Tiny College _SQL. I don't have Oracle yet. I do it, but it's easy to use MySQL, and I've used it quite a bit in actual applications. So I'm fairly comfortable with how to break it. So download that, and then go visit our wonderful admin.ms.edu page. Anyone know the Wilsons? Terry Wilson, Ashley Wilson, Laurie Wilson.
Yeah.
Their father, Terry, is coming to Dubuque. He's been working at Lilo Camp in New York. He's going to be the new director at ECS. He's a good friend of mine. So admin.ms.edu/phpMyAdmin. And I have given you each your own login. You can use your last name and no password will get you into the database.
No password. What is your
Let me make sure that works. Oh, I guess it doesn't work. I thought it would let me in. Maybe.
cs312.
Yeah. I have to go fix the real. I thought it would let you in without a password because it let me create a user without a password.
Wow, Baker
And I've created all these cs312 databases, but you can't do anything with them until you're logged in as that person. Maybe I'll just assign cs312 can change it.
This would be
Okay.
a perfect time to teach us SQL injection, right?
Yeah, you're right, that's right. You're going to see the SQL.
So
Go ahead and examine the SQL there. So I have to change the privileges here. I'm going to add the user cs312.
Also, I don't see my name in that list.
Oh, I forgot to put Shirley in there. I thought I was missing somebody.
Good job. Good job.
Let's see if this will work now. So I'm adding cs312 to the what table? To the Allstat table.
I go download the text.
Okay. Oh. Let me go back to the Allstat table, and I need to edit privileges.
So would if people actually write this stuff by hand, this SQL,
Yes, they actually do.
all the data, like with all the insertions, that sounds like.
Well, typically you'll write code that it does the inserts after reading through the data file. They'll process a
So you have
CSV.
like a script that'll.
Yeah. And let's see, I need to, let me do this. Maybe, well, that's the privileges. I don't want to pain it. I know how to do this. Maybe I just have to do it SQL-wise. All right, I'll do that. Here we go. Here's your first SQL lesson here. I want to give cs312 full access to the cs312 Allstat database. So here's how it's done. Grant all privileges on cs312 _ Allstat.
Did you check mark the grant box?
No, I'm doing it by SQL. I'm not even doing any grant than any user interface. This is raw MySQL to cs312 at localhost. And when it returns empty result, that means it's working.
That's great.
That is SQL code to grant all privileges to a specific users. So now, if you're logged in as cs312, you should now be able to go mess with the Allstat database. And I'm going to grant it to the Baker database as well. And I'm going to create the cs312 Charlie database. Are you able to get to it now? All right, for the bell, I'm going to grant access to the bell database to the cs312 user. This is the part. This is how you designate a specific user in the system that has privileges on a specific database
Do cs312 underscore last name or
at localhost. See, this is the user that we already have, right? cs312 has password cs312. Now this is granting that user full access to the cs312 bell. So rather than making a separate bell user, the cs312 user can modify that table.
And if you wanted to reject all privileges, just put deny.
Yeah.
Is there a McCoy or is he Tiny College? Are you Blake Tiny College?
I don't know.
How do you want us to log in again?
If you're logged in as cs312, you should see the privileges. Did I already do George? Yeah. I forgot Blake too.
I see no George. I mean, I can see that George.
Well, let's make sure I did the grant. And I better make the database McCloy too here.
There we go.
MCCLOY, right?
Yep. So should we just import the table? Import the
Yes,
table?
yes, you're just going to import that data. That's how easy it is.
Oh, that's what we're doing.
Now that you have your database and you can get to it, and you're logged in as cs312, now I can go to any table now. Let's check. And I can see privileges. And now I see that cs312 has all privileges granted to them. You even have grant privileges. That usually, by default, you're not, a typical user isn't given grant privileges. You only have full edit, but you can't give other people full privileges on your database. Okay, so now I'll go create mine now, just to show you how this should work now. I'm going to create my cs312 Manning. And I've just been using the collation. For us, the collation doesn't really make a big difference, but rather than have some strange collation, I use the UTF Unicode. So you have to go to your table that belongs to you, and then you do a import. And you browse for that file that we just downloaded.
okay, from the rearranged.
The one that, the SQL one, the text one, not the database. The little text file. tinycollege_SQL.txt. And before I do the go, I'm going to go see what's in that file and bring my little file explorer up. I browse to where that file is. I can now learn a little SQL. I'm going to open that ch04 Tiny College in Notepad. This is actually SQL code, my SQL code, that creates the table.
We were supposed to do like the code that we did Wednesday, right? The brand, manufacturer, that one's what you're wanting us to import, correct?
No, just you can import the Tiny College. Or wait a minute, let me check my instructions. I thought it was Tiny College, but there is that other one. He did give us, what was the name of that? Was it Short? What was the name of that other company? I'm not sure. Was it Partco? Let me check my instructions. Oh, are we done?
Yeah.
Man, we're out of time. Let me check the instructions. I thought it was the... Oh, this one. This is the same thing we did with we could do with the other one. If you export the table you had, you get that exact SQL code that you can import and create tables. So that's the wonderful thing about when you export to recreate your table. If you look at the actual code that was generated, this one here has a create table class. When you do an export, it does a create if not exists. So it will recreate your table if it's not already there. But this is the code that actually injects the data. Well, I wouldn't call it injecting. It inserts the data into your table. And this is when you do SQL injection. This is the code that they will fool the processor into inserting, such as inserting into logins or the user table my username and my password now with full privileges. And that's how they'll get into systems that they know have a database controlling access. But look at this long table. It's mostly the insertion of the data, the creating of the tables. This is the definition of every field in the table in the create table command.
So which one were we supposed to import? Sorry.
The text file.
Yeah, just do the Tiny College. And we can review that on Monday.
So you just go to import, choose, and then Tiny College?
Yep, the text file. And remember, you can always go back here and you can, if you didn't like what happened, you can go to operations, or you can go to structure, you can do a plus. You can drop any tables if you go to your structure. If you want to try it over again, just drop some tables. Say I go to I've imported the Tiny College. I could select all my tables, and down here I could do drop and recreate all my tables.
Mine's not allowing me to import.
I guess you can't mark. I said you can't put that one on top of that.
Are you and you're logged in as cs312? So Baker. If I look at Baker privileges. Uh-oh. I thought I had done this. There we go. Now Baker should have privileges. Let me check. Yes, it's showing CS312 now as privileges on the Baker table. So now you should be able to import and should complain. Now this is more the low-level SQL code. The chapter is more going over understanding relationships and why it's important to establish them. It lays out your structure of your database. But more of that on Monday. Oh, and I'll finish the recording.